with the Viterbi algorithm. In the Viterbi algorithm, the question is like this one. Here they will give one sentence. Our test sentence is I love coding. What kind of part of speech? POS. Final answer is POS tagging. I means noun, love means model, and coding means verb. Like that, we will get the part of speech tagging. That is our outcome. So here the given constraints are, this is the transition probability. Transition now, it's a probability from moving one state to another state. Similarly, the emission probabilities are given. Emission probabilities in the case, output probabilities. Same manner, initial probabilities are also given. So transition probability in the sense here PRP to PRP, the probability is 0. Nothing can be moved from PRP to PRP. Similarly, PRP to MD, the probability is 0.8. PRP to VB, the probability is 0.1. Like that, these are the given scenarios. For this, by using this scenario, we are going to mark the part of speech tagging for our I love coding. This is your question. We'll solve this question. For solving this question, first draw the transition diagram. That is important. Draw the transition diagram. And these are the steps required. Initialization, recursion, termination, and backtracking. These are the 4 steps required in the Viterbi algorithm. Initialization, recursion, termination, backtracking. Draw the transition diagram. To draw the transition diagram, consider the things given. What are the things given? What are the part of speech given? PRP, MD, PB, NN. Similarly, the sentence is I love coding. I love coding is the sentence, and these are the given probabilities. So first write I love coding. For I, write all the things PRB, MD. Here already it's given that PRP, MD, BB, NN. So write all these things PRP, MD, BB, NN. For I, for love also you write PRP, MD, BB, and NN. For coding also you write PRP, MD, BB, NN. We are going to find the possible connections from first I to coding. That is our objective. Okay, this is the transition diagram. First write the given sentence. I love coding. For I, write all the possibilities. Love, write all the possibilities. Coding also, write all the possibilities. This is the first step. And your second step is there. This is first step. Then go with this one, initialization, recursion, termination, backtracking. First do the initialization. Initialization of first. Initialization is done only for the symbol I. For I only we are going for the initialization. For initialization, how to find the initialization in the sense, first PRP, MD, BB, NN. For all this one, you should calculate the initialization. So for PRP, what is the initial weight? How to calculate the initial weight means, first they have given one initial weight for PRP into find the emission weight for PRP for the letter I. For the letter I, in PRP, find the emission. B means emission probability. A means transmission probability. And pi is the initial probability. Transmission. A na transmission. Pi is the initial probability. So first find the value for I. So go and search here. Here PRP. Go and search here. What's the initial weight of PRP? 0.5. So that is taken first. PRP initial weight is, so to understand this one, the initial weight is 0.5 into, in the emission table, first take this PRP initial weight into, go and check the emission probability. For the emission probability, first we are dealing with the first sentence I. For I, the emission probability of PRP is 1. Okay. The emission probability of PRP is 1. So 0.5 is equal to 0.5. That is given in here. 0.5 into 1 equal to 0.5. Same manner, find the initial weights, initial probabilities, initialization weight for all things. So for MD, you calculate what for MD, what is the initial weight? 0.2. Initial probability is 0.2 into the emission probability for I. We are calculating for I. Remember that we are calculating for first state. So emission probability for this MD. Emission probability for this MD is 0.00. So the answer is also 0. Similarly, for initialization of BB, initial weight is 0.1 into emission probability is 0.00. So that is equal to 0 only. Here also the value is 0. Automatically we will get 0.2 into 0, that is equal to 0. For this PRP only, we get the weight, initial weight 0.5. All other weights are 0. So no need to consider other nodes in the first stage. Only consider the PRP in the first stage. It can be defined by the emission probability. If the emission probability is 0, automatically you will get the probability as 0. The meaning is there is no possibility for obtaining that word. That's the meaning of the emission. There is no emissions in that particular word. So if the emission probability is 0, no need to process that. Automatically you will get the word as 0. Now you go here. Here the maximum value is 0.5. This is the first stage. We found the initial weight 0.5. You see this figure. Here PRP, for the PRP initial weight is 0.5. For the remaining things, the weight is 0. So no need to process from the remaining things. Now find the probability of getting the word love. Love is the second word. Find the probability of getting the word. For that one, you will calculate the probabilities. Only possibility is PRP, right? From PRP only, you can process the string. So here now you find the weight PRP to PRP, PRP to MD probability, PRP to BB probability, and PRP to NN probability. To find this probability, we should find the initial now the initial probability of PRP is 0.5. So initial probability into, now we are transferring from PRP to PRP. Transfer, now what's the meaning of that? The transmission probability. How can you define the transmission probability? A of PRP to PRP. Moving PRP to PRP, what is the transmission probability? And here you are stopping here. So emission probability. Emission probability B of PRP. So three probabilities: initial probability into transmission probability into emission probability. Calculate this one. That's the second step. For love, we are calculating. For the word love, we are calculating PRP. Only possibility is PRP. From PRP to PRP, PRP to MD, PRP to BB, and PRP to NN. If you see the emission probability table, go and see the emission probability table. The emission probability table for love, we are calculating for the second word, right? So love, when you are calculating it for love, the only possibility is PRP, the value is 0. And NN also the value is 0. So no need to calculate PRP to PRP and PRP to NN. Why? The values are 0, not at all possible. So calculate the weight from PRP. Calculate the probabilities from PRP to MD and BB. PRP to MD and BB. Okay. Calculate it from recursion. This is the second step, recursion. So no need to calculate from PRP to PRP and no need to calculate from PRP to NN, because for these two things, the emission probability for love, only for love, the emission probability is 0. So definitely you'll get 0. No need to process the things in red color. Instead, calculate for MD and BB. For MD, we are calculating it from PRP. So PRP, initial weight of PRP, we have calculated the initial, what's the initial weight of PRP? 0.5, right? So initial weight of PRP into transmission probability of PRP to MD. PRP to MD. Now see here, PRP to MD. What is the transmission probability? It's given transition probability of PRP to MD. That is 0.8. Take it from this table, 0.8. So this is 0.8. Again, emission probability of MD for love. Emission probability of MD. Here, this is the emission probability. Emission probability of MD for love. That is 0.9. So 0.9. This 0.36. Same manner calculate for BB also. When you calculate for BB, you are calculating from PRP. So initial probability of PRP. Again, your transition is from PRP to BB, PRP to BB. And for love, what is the emission probability for BB? So we know that 0.5 is constant here. Go and check in the table, transition table as well as the emission table. You check it in the transmission table as well as the emission table. In the transmission table for BB, that for transmission table PRP to BB. PRP to BB, the value is 0.1. Okay, 0.1. Take this 0.1 transition probability. And for emission probability, we are calculating for love. For love, find the BB probability here. 0.1. So 0.5 into this 0.1 into this 0.1. Take these three things. 0.5 into 0.1 into 0.5. Here the value is 0.05. So these are the two possibilities because only PRP node only having weight. Other than that, all weights are 0. Now I have calculated the possible probabilities from PRP. Only two possibilities, 0.36 and 0.005. Which one is having the higher priority? That is, which one is having the higher probability? This is having the higher probability. So mark that one. Go to the next slide. Here from 0.5 to MD, the value is 0.36. And PRP to VB, the value is 0.005. These two values are taken. Now, you should not find the transition from only the MD. There are two possibilities. Two possibilities are there. For all these two possibilities, calculate for the next one, coding. Now calculate for coding. Next recursion. So all you calculate first, calculate from MD to PRP, MD to MD, MD to VB, and MD to VN. Okay. Then calculate. VB is also there. There is a path for VB. VB to PRP, VB to MD, and VB to VB, VB to NN. Before calculating this one, find the emission probability. If the emission probability is 0, no need to calculate. No. So for the word coding, emission probability, go and check. Emission probability for coding is PRP and MD, the emission probability is 0. So there is no possibility to move to PRP and MD. Coding is obtained only in the verb or noun. Probability for verb is 0.6. The probability for noun is 0.4. So no need to process for PRP and MD. That is here in this. No need to process for PRP and MD. Instead, you should process for MD to VB and MD to NN. Same manner. From VB to PRP is also not possible because PRP the value is 0. MD also the value is emission value is 0. So no need to calculate. If emission probability is 0, it won't be available. No need to calculate. Now calculate the remaining things. Now calculate for the coding MD, VB. Two possibilities are there, MD and VB. So first I am calculated from MD to VB and MD to noun. MD to VB and MD to noun. So initial probability of MD into transition from MD to VB and the emission probability of VB. Emission probability of VB. So 0.36. Now it's changed to 0.36, right? Now the weight of here is 0.36. So 0.36 into MD to VB. What is the probability MD to VB? MD to VB. The probability is 0.7. So MD to VB, the probability is 0.7. 0.7 into the emission probability is given as 0.6. So you are getting this value. Same manner, MD to NN. Find all the values. You get this value. So from MD to VB and MD to NN, these two are the values. Same manner, calculate from VB also, because VB node is also active one. No? VB also some values are there. So for VB also calculate VB to VB and VB to NN. So VB to VB. VB to VB means initial probability of VB into transition probability of VB to VB and coding probability. For coding, what is the probability? Emission probability of VB. Calculate these things, you will get 0 and 0.0017. I have mapped all these things. These are the four possibilities. MD to VB, MD to NN, VB to VB, VB to NN. These are the weight. Now see the maximum probability. Among four values, what will be the maximum probability? 0.1512 is the maximum probability. So fine. So here the recursion is over. First we have calculated the initial weight, then recursion to this hidden node, recursion to this node. This is completed. Suppose one more word is there, we should find a recursion for that also. I love coding. In is also there, means suppose in is there, means for that one also you should draw PRP, MD, VB, NN, and here now VB is active. 0.1512 is there in VB. Take the maximum probability. Among these two, the maximum is 0.0432. So from VB to PRP, MD, VB, and NN calculate. Same manner, we should calculate the next step also. If it is there, the word is there, that is given in the question also. Calculate all these things. Then final one is termination. Termination and backtrack the tag. So termination means where the past maximum probability is there, terminate in that step. In our example, the maximum probability is there for BB, no? MD to BB, the maximum probability is for BB. So BB is the final node. For us, BB is the final node. Then backtrack. Final node. From the final node, see the previous one with higher probability. Here, this is the Markov chain model. First one, then probability of second one, probability of third one, next. Finally, you backtrack. Now, the probability for MD to BB is high, no? So, the backtrack the node to and go here. So, MD, the probability, this probability is high. Again, backtrack. Here to here, only one path is there. So, this is the path. So, when you are looking over this one, coding belongs to. So final node selected is VB. When you backtrack, then the intermediate node selected is MD, and again backtracking the initial node selected is PRP. So part of speech tagging is I belongs to PRP. And what's the next one? Love. Love belongs to model. Love is one kind of model in the defined one. This is the model. Love belongs to MD. And what is the next one? Coding. Coding belongs to verb. In the hidden Markov model, by using Viterbi algorithm, this can be, the given sentence can be tagged finally. In this example, terminate in the final state and backtrack, you will get IPRP, love MD, and coding is the VB. These all are about the Viterbi algorithm. Okay, thank you.